Hi, everybody. Welcome back to the AutoML tutorials organized by the tinyML Foundation. Thanks a lot, Rosina, to have organized this session. And today, this is another episode of the deep dive on AutoML for tiny devices. This time will be held by Qeexo, and in particular by Cora and Michael. Short introduction before to leave to them the floor. These events, like others, could not be possible without our tinyML strategic partners, which are helping and bringing this community to the next level. A lot of them are very active. New one will join very soon. And there are multiple ways to communicate within the community. One excellent method is through Meetup. In Meetup, you can also increase your network with other peers, other experts in the community, as well as to use the social like LinkedIn. And then don't forget to subscribe to the YouTube channel. There are a lot of subscribers, a lot of video content. You can learn a lot, and more content will be published soon. This is an excellent media and way to learn about the rich developments that characterize the community from multiple experts within it. The next episode after this with Qeexo about the deep dive on AutoML tutorial will be organized by SensiML on July the 20th, usually at 8 a.m. Pacific time. And then I'm quite excited to let you know that end of August, August 31st and September 1st, there will be the first forum on on-device learning that I have the privilege to chair. So stay tuned, because this is going to be an amazing event to assist and to participate. And then don't forget to apply to the call for presentation for tinyML Innovation Forum that will be organized in Cyprus, October 10 to 12. This will be in-person event. Organize yourself, be there, contribute, and send your proposal for presentation till August the 1st. The experts are Michael Gamble, which with a wide range of expertise in software as a service, software engineering, robotics, process automation, and machine learning, has 10 plus years of experience building and leading product teams to develop innovative software solutions supporting the automotive, industrial, manufacturing, and media and entertainment industries. Cora Zhang is a machine learning enablement engineer from Qeexo, who actively works to bridge the gap between engineering, business team, and customer teams. Cora has a strong passion to harness the power of machine learning and drive business impact. Cora has intentional pursued to masters in data analytics and MBA, which enables her to analyze problems and create solutions with business acumen. And therefore, go Qeexo. The floor is yours.
So thanks again, Danilo, for the warm introduction, and good morning, and thank you all for attending the tinyML Foundation's AutoML Deep Dive with Kixo AutoML. So again, my name is Michael Gamble, Director of Product Management here at Kixo, and I'm joined by my colleague, Cora Zhang, Kixo's Machine Learning Enablement Engineering team lead. This morning, we're here to lead you on a workshop of Kixo AutoML, which is a brilliantly simple, fully automated, no-code machine learning web app for embedded devices. But before we jump right into this, I wanted to share a bit about who Kixo is and what makes Kixo AutoML such an amazing product for all users at every stage of the machine learning development process. So starting right off, who is Kixo? Kixo is a machine learning company founded in 2012 and spun out of Carnegie Mellon University. We're headquartered in Mountain View, California, with offices in Pittsburgh, Pennsylvania, and Shanghai, China. Kixo currently operates two key product lines, which is our tinyML SaaS applications, including Kixo AutoML and Kixo's Model Converter, along with our machine learning applications product, such as FingerSense, EarSense, and Touch Tools. Kixo's diverse culture and experience encapsulates a customer base that spans across Fortune 500 industrials, manufacturing, food processing, mobile, and more, with Kixo AutoML being used to build and deploy machine learning solutions at more than 300 million units across 260 various devices worldwide. So how did we get our start, and really what's the inspiration for Kixo AutoML? So Kixo's origins are rooted in machine learning applications supporting mobile phone OEMs. During go-to-market of our first major product, FingerSense, which is an elegantly simple machine learning application for smartphones, we experienced many challenges. One of the most significant was in the form of scalability, which came from a bottleneck during the tuning of our ML models for each new mobile device, where each unique industrial design of smartphone required some optimizations of the ML models and required the effort of minimum 4 machine learning engineers working full-time for 2 months. So understanding at this rate, it may not be feasible to meet our customers' target of supporting 60 mobile phone models a year through manual processes, the Kixo machine learning engineers set out to create an internal automated solution which captures our machine learning and embedded capabilities, automating training and deployment while distilling down the machine learning process into easily manageable discrete steps. It was during this time that the first iteration of Kixo AutoML was born. A streamlined, fully automated machine learning pipeline, which no longer required the effort of our expert machine learning resources to complete these repetitive tasks. A huge efficiency driver, this allowed our junior technicians to focus on various processes required in scaling the solution to each new device, while freeing our machine learning experts to work on improving and extending the system. The result, using Kixo AutoML, we successfully scaled, deploying FingerSense to over 260 unique mobile phone models across 300 million devices in just our first 4 years. So all in all, we were really our own first success story here. So that was then. So what is Kixo AutoML today? So today, after many iterations, Kixo AutoML is a fully automated end-to-end machine learning platform, providing users with the ability to rapidly collect and edit sensor data, train and evaluate models and metrics, and deploy and live test up to 17 different algorithms without writing a single line of code. Built for speed and efficiency, Kixo AutoML's no-code platform reduces time and dependencies on expensive ML resources, drastically simplifying the deployment process and increasing scalability. Simple and intuitive, Kixo AutoML has been designed to support the needs of machine learning practitioners, embedded engineers, FAEs, and domain experts alike. Since Cora will be providing a full live demo in just a couple moments here, I'm not going to go through all the details of the Kixo AutoML user flow, but just before we get there, I wanted to provide just a bit of a visual on one of the key benefits of Kixo AutoML, which is efficiency. So as you can see here, after data is collected or uploaded to the platform, all of the machine learning steps shown here in blue are automated behind the scenes, really starting with data cleansing and pre-processing through another one of Kixo's key differentiators, C code conversion and compiling the target hardware specific ML package, essentially creating a model in embedded C optimized for the resource constraints of the tinyML target. So by automating and managing these and many of the most other tedious steps and putting in some guardrails, Kixo AutoML dramatically reduces errors and the time to build machine learning models. So wrapping up here with some key values before moving into the demonstration, Kixo AutoML harnesses the full power of a team of experienced machine learning, sensor, embedded, and software engineers in a no-code, fully automated tool, enabling users to build and deploy production-grade ML applications in minutes and scale their solutions all behind a simple, easy-to-use GUI optimized for field calibration and deployment. So it's really a great tool for all stages of the ML process, as I mentioned, and we really encourage you to sign up for a free account and check it out for yourself today. So now I ask you to turn your attention to my colleague, Cora Zhang, who will lead us on our live demo today.
Hi, everyone. Thank you, Michael. So it's a pleasure to give you a Kixo AutoML demo today. Since Michael have already introduced you about Kixo, I'll just jump right into the demo. So today I'm going to show you a gesture demo, and I'm going to build a machine learning model to detect the different gestures, which are wipe, tap, and resting. So the device I'm using here is ST-Win. Yeah, okay. So when a new user signed up and then log in for the first time, then they will land in this create project page. Here, you can start with entering a project name. So I'm entering gesture demo ST1 here. And then moving forward, you can select the classification type. And then we support 3 different types: multi-class, single class anomaly, and multi-class anomaly. So I'm going to choose multi-class classification, and moving forward, you can choose the target hardware that you are using for your project. Here we support different hardwares, including some of the Arduino sensors, ARM virtual hardware, PNG, and ST. So for ST sensors, you can run your model either on MCU or MLC. So, and then you can go ahead and click create. Since I have already create one, so here it is. So after you create, you will be landing in this page. And then here within this project, you can do the data collection, train your model, and then do your model evaluation. And then you can manage both training data or test data here. And then there's 2 ways for you to collect your data. One is to upload the previously collected data, or you can just collect the training data on the spot. Today, I'm going to show you how to collect the training data on the spot. And we can go ahead and click this button. And then you will be landing into this new data collection page for training data. You can just simply start entering a environment name that is tied to your physical environment. And then you can go ahead and click save. And then now you can do the sensor configuration. So depending on different sensor device, we are supporting different sensors. For ST1, those are the sensors that we are supporting, all the way from accelerometer to temperature and current. So since this is a simple gesture demo, we're going to select accelerometer, and then we can go ahead, choose the sampling rate. Once you do this, you can click the Flash Data Collection app button. And then what this will do is it's flashing the data collection binary to the sensor device here. And once it finished, then you can just go ahead and then do the data collection. 2 informations that you need to enter here, which is the collection name and the number of seconds that you want to collect data. To show you a simple example, I'm gonna collect 10 seconds of tap data here, and then you can just go ahead and click record. And then you will be landing into this new page. And then you can just start clicking the start button, and then in the meanwhile, you can start collecting the data. So I click start, and then I can start tapping this sensor to collect data. So since I'm just showing you an example, I'm only doing 10 seconds here. Okay, once your data finished collecting, then you will be seeing your data showing up here. You can click this visualization button to give a look of your data. And then going back to this page, you can click as many data as you need, continue repeating this process. So once you finish all the data collection, you can circle back to this data page, and then all the data will be listing here. So you can still click the visualization button here to view your data. One thing I want to highlight about Kixo AutoML is we have a feature called segment. So this segment is a function kind of allow you to slice your data into different chunks. Basically, this will be helpful if your data is event-based or your one single data collection, including multiple multiple classes. So basically you can crop your data into segments and only use this part for your machine learning model. So here I have a data collection called all-in-one. It's 60 seconds data that I collected, including all three gesture, wipe, tap, and arrest. And I'm just gonna go ahead and then click the segment button here. And then you will be landing into this data segmentation page. So here are the segments that I previously created. To create the segments, what you need to do here, just simply click the create new segment button and then assign a name. Let's say I'm gonna do the segments for a tab and then choose the color and then click create. So here, moving forward, optionally, you can drag in this bar to zoom in your data. And then all you need to do is simply click the start and end point that you want to crop. So these are the tab gesture because tab is event-based. So it's kind of separate. And then by doing this, you will automatically here see three automatically generated segments. And here are the previously segments that I created of wipe and rest. So once you finish all the segments, you can go back to the data page. And in our future version, actually you don't even need to do so. All you need is, we have a feature called assisted segmentation. So all you need is to do one segment for a class, and then we will do the rest for you. So that feature is coming soon. And now let's circle back to the data page. Here I have three previously collected data of all the three gesture. Each of them is 30 seconds. And then these are the data that I want to use to build my machine learning model. I'm just gonna select all of them. And then now you can click the Start New Training button. Once you click, you will see a pop-up window. Firstly, you will see group label option. So this is a feature that if you want to group two class into a new class, let's say this machine learning model, I don't want it to be a 3-class model anymore. I want it to be a 2-class and movement versus not movement. Then you can just go ahead and then group tap and wipe into movement. And then you can go ahead, click save to proceed. But here we're just gonna skip this step. Sensor selection, we have two options. One is automatic, one is manual sensor selection. So if you are quite confident or you know which sensor matters to your model, then you can just go ahead to select it manually. For example, if only x-axis of accelerometer matters to this model, then you can go ahead and select this two and only including this one for your model. By choosing automatic, that means Kixo AutoML will help you test different combination and then select the best performing one for you. And we also have feature selection. You have option of manual or automatic. And here are all the feature selection option we have here. So for today's demo, we're just gonna go with automatic. And then you can click next. Inference setting. So here you also have the option of automatic and manual. Two figures that you need to enter. One is the instant length, one is the classification interval. So instant length is the time length of the data that a software will use to make a prediction. And classification interval is means in what time duration your software will make a prediction once. So since I don't have a specific number to put in here, I'll just do automatic. That means Kixo AutoML will help me select the best number and then you can click next. So as Michael mentioned before, we support up to 17 machine learning algorithms on our platform. And if you don't have a specific algorithm that you want to use, then you can just go ahead and then select all of them. And then once you select all these machine learning models, you can just click next. Here, optionally, you can choose to turn on the learning curve or the hyperparameter tuning. Turning it off will help you save some processing time. And then you can click Start Training. Once you click, the training process will then start it. So as you can see, it's showing pending now. So once it's done, it will show as ready. Just to save some time, I'm gonna show you a previously trained model. So once all the process finished, this is what you're going to see, all the machine learning models with their cross-validation score, the latency, and the size. And you can also click this performance summary button here. Once you click, you will be seeing multiple metrics. For example, confusion metrics, learning curve, F1 score, to help yourself better understanding your machine learning model. And here we support 2 ways for you to evaluate your machine learning performance. One way is general, using test data. So just to help you record in this data page, you can manage your test data here. So here I have a data that I uploaded, which is the tab data. And then going back to this model page, here you can click this button, edit test data, and then your test data will show up here. What you need to do is to click the checkbox here and then match it with the correct data class. And then you can click save to start the evaluation process. Once this process is finished, the result will display here. As you can see, you have all the model and its model performance for test data. Alternatively, you can check the performance here as well. And also, you will be seeing the confusion metrics for test data as well here. And this is one way. Another way for you to do evaluation is our live test feature. So basically, you can do a live classification. What you need to do is compare your machine learning models and then select the one that you're most interested in. And then you can select, let's say we select a logistic regression, and then you click this push to hardware button here. So what this do is to push the binary to the sensor. And then once this finished, the live test button here will become clickable. So this may take a few more seconds here. Okay, so it shows flashing successful. And then we can go ahead, click the live test button here, and then you will be landing into this live testing page. Currently, we're supporting 2 hardware connection methods. One is USB, one is Bluetooth. In the coming future, we are going to support Wi-Fi connection as well. Since my sensor is connected through the USB, I'll just choose connected through USB. And then you will see the classification right away. Because the sensor is not moving right now, it's showing rest. But I'm just gonna wipe the sensor here, and then you will see wipe. And if I do the tap, then you will see the tap. If I stop moving the sensor, then it will show rest now. So this feature will help you to detect whether your model is having some flickering or not, or if your model has some serious latency issue. This is where it becomes really helpful. So yeah, this is all the demo. Thank you.
So just kind of wrapping up, as Cora mentioned, this concludes the live demonstration portion of this project. I'd now like to open up the floor a bit more to anybody who has any questions, comments, or concerns. So I've been kind of in there trying to answer a few of these questions here. We've gotten quite a few questions on supported hardware. So let me just I'll just address that again at the moment. Our current supported hardware for Kixo AutoML, just for general availability, so supported right out of the box, is two hardwares from ST Micro, which are the SensorTile.box and ST's ST-Win device. Both of them are really great devices. In addition, we have we have support for Arduino's Nano 33 IoT, as well as Arduino's BLE Sense. And then coming towards the end of the month, we'll be supporting the Arduino Nicola Sense Me, as well as all of its sensors, gas sensors, IMU, and other environmental sensors. So we're really, really looking forward to that. Other questions that I'm seeing here is, can we give a real life application? So, kind of not exactly trying to, name any type of customer names. We do some, we have deployed intelligence to logistics machines using various IMU sensors that really support the alignment of various automated processes. So trying to be really vague in describing the issue here. We are working with some customers in which they are trying to move materials across the floor of a factory, and as all machines, all automated process machines, they all need to be serviced, and one of the faults here is it could come out of alignment. So what we do is we do some condition monitoring there to say, hey, we've deployed a machine learning model that says, hey, you might want to work on getting the technician over here to this machine to realign it. We think that, it's going to break down, or we think that it's going to jam up. And, obviously our customers hired us to increase the efficiency of their factory or their processes. So this is, something that the customers are really appreciative of, in the sense that says, hey, get the technician over to a machine that might have previously have been ignored. So sorry about the vagaries there. I can't speak too deep about our customers, but that's one of the real world applications, but we see real world applications everywhere from, gas detection all the way down, or environmental air quality detection all the way down to fitness tracking and other types of industrials. So with regard to the additional hardware supported in the future, we have a list of strategic hardware that we're looking to support, and we're trying to add is new hardware support, regularly. I don't have exact specifics on the hardwares that are proposed, the ESP32, as well as the ESP RE SSIF. But please keep an eye out for our newsletter, keep an eye out for our website. These, like I said, we're looking at supporting different hardware all the time. So one of the questions is, can you download the firmware for editing? That's came through the chat. So answer is yes. Pro tier accounts have access to download their static library files, as well as a binary file of their model at the end of the after training. There's one more question here. Do you support LSTM or GRU and multi-level? Are there any compressions performed for the models? This is being on the product side, this is a bit out of my technical capabilities, but whoever asked that question, I'd be more than happy to gather those answers for you. My email, as well as Cora's email, is right here on this last slide. So just feel free to drop me an email, and I'll work with my team to get that answered for you as best as I can. So I'm getting another question here, free community account. So yeah, so the free community account, pretty much 95% of Kixo AutoML is free. Basically, when you want to commercialize your application, you'll need to buy a pro tier license. I think that Cora, if you can you drop the tier, the link to the different tiers in the chat if you get a chance here. Just off the top of my head, some of the restrictions for a free tier account is it's restricted to not being able to download that static library as well as the binary file for your models. You're also limited in terms of like size and storage, and then there's a couple models that are also restricted for free tiers, some of the neural networks that are just really process heavy. Yeah, so Hadar, like the firmware is in C.
Yes, thanks a lot, Cora and Michael, for your dedication in preparing the deep dive on the Qeexo AutoML solutions. That is very appreciated, and I think also the questions you got were very interesting and a kind of sense of interest that the community has on your solutions. It's important to say that this event, like the others for the deep dive on AutoML for tiny solutions, has been organized thanks to the great efforts of the strategic partners, which are bringing all the operations of the community at the next level. And in particular, let's go quickly through the executive strategic partners. ARM, which is a leading company producing the tiny devices all we know. Edge Impulse, who lead the development and deployment of platform for Edge ML. Qualcomm. Sentient, to accelerate edge compute within a low power envelope. Thanks also to the Platinum strategic partners, such as DeepLight for fastest video analytics solutions on ARM CPUs, Clicatech for global IT solutions, Reality AI, and Renesas, Sony Semiconductor Solution Corporation, and also thanks to the gold strategic partners such as Analog Devices, PhotoHub, Latent AI, NXP, Seed Studio, tinyML, ST Microelectronics, Synaptics, SynSense, and all the silver strategic partners such as ON Devices, EMSA, Green Waste Technology, Groverty, OTG, ImageBob, Itemis, Note AI, AutoML, Prophecy, Qeexo, Rexen, SAP, Silicon Labs, Stream Analyze, and TDK InVeSense. Thanks a lot for your attention and for all the time you devoted in preparing and attending to this event. See you at the next one. Thank you.